Oh, the world of Minecraft, a game that offers more than meets the eye. From a marvelous creation to a humble shack, Minecraft is a game that has entertained millions because of its endless possibilities. But what does physics have to do with this 8-bit sandbox game? Physics, or the study of the physical world, relates directly into survival Minecraft. When programming the game for survival, some sources of forces, the main components for physics, had to be implemented. Today, I'm going to take a look at gravity, one of the natural non-contact forces on Earth and throughout the universe, and what is the difference between Minecraft's physics and the real world's physics. It's common knowledge that gravity between anything on the surface of the Earth has an acceleration of negative 9.8 meters per second squared. It's already been discovered. It's already just a common fact. This basically means that there is a negative force acting on you that counters any other positive velocity acceleration and forces on you back towards the center of the Earth. Basically, this is what holds everything on the ground. This is a common physical law of Newtonian classical physics, also known as Newton's law of gravitation. On a visual note, an example in Minecraft, assuming that the artificial gravity in vanilla Minecraft is the same as the Earth's, if you are 6 meters or blocks above the point, it will simply move down, closer to what would be bedrock, or the center of the Minecraft world. Mathematically explained, if you jump off of those blocks, you will move in a negative y direction. If you open the F3 stat screen in Minecraft, you'll be able to see the y is going down, in this case 6 blocks. Players are also able to see their coordinates on a 3-dimensional XYZ coordinate system. If I start from height y and jump off from that point and land on point y2, then the distance I covered is y2 minus y1. So what we're really trying to find here is the gravitational acceleration, not necessarily the gravity, or the gravitational acceleration caused by the gravity between you, the player, and the Minecraft world. To do this, we're going to use the formula F of g, or the force of gravity, equals big G, m1 times m2, divided by radius squared. The radius is going to be the radius of the planet per se, m1 is going to be the mass of the Minecraft world, or the mass of the Earth in some instances, and mass 2 is going to be either the mass of the human or the average mass of a Minecraft player. So we definitely have to do some calculations in order to find some of these out. Also, big G is simply a universal constant discovered by Isaac Newton. After staring at this equation for a long time, I often wondered if we needed to redetermine big G, but this value basically works in every form of gravity equation, so there's no need in recalculating something that is already universally proven. Even though that this is a virtual world, we're just going to assume that it works in this virtual world as well. Calculating the mass of an average Minecraft player is actually fairly easy. We should just use the average mass of a human on Earth, which is 62 kilograms or 140 pounds. Now, calculating the mass of the Minecraft world, not that easy. It's going to take a lot of calculations, but basically here's what I've found. So, considering that the circumference of the Minecraft world, or from any point from one side to the other in a Minecraft world, is 60 million meters, if one block is equivalent to a meter. So, while the Earth's circumference is only 40 million meters, so actually the Minecraft world, in theory, is 33% larger than the Earth that we live on. Keep in mind, there is actually a way to take the mass of something like a rectangular prism and compare it to the mass of a sphere, or turn a rectangular prism into a sphere, but the easiest thing to do is actually turn it into a cylinder, which is what we're assuming that we're doing here by taking a radius and a circumference. If everything is correct, basically what we're going to do is take the radius and the mass of the Earth and multiply both of them by 1.33, which will raise both of it by 33%. Now you're probably wondering, how do all of these cubes form something circular like a cylinder? And it actually is really simple. Considering that the square of the Minecraft world is 60 million blocks apart, the theta at which the blocks have to be turned in order to make a circle in the end is so minute that you probably can't even notice. So, in theory, it's kind of as if the Earth was once believed that it was flat, because it's changing at such a minute rate that we can't really see that it's circular, even though we now know that it is basically a sphere. It's so small that it's on the verge of inexistence, but it's still there. We can visualize this if we think about plant cells. Plant cells in trees. Trees are basically very tall cylinders, even though plant cells, or most of them, are square. So it works the same way. Since there's so many cells, they're able to align themselves in with angles so that they form something round. For this video's analysis, I'm not going to be redetermining big G, or I'm not going to be questioning if it's even relevant anymore in today's Earth, and I'm not going to be questioning if we should take the mass of something like a rectangular prism in the Minecraft world and saying that it ought to be a sphere. We're instead going to assume that it forms a cylinder, or at least a cylinder type shape, and we're going to take the mass, multiply it by 1.33 to get a 33% more, and we're going to do the same thing with the radius. So, considering the Earth's mass is 5.972 times 10 to the 24th power, multiply that by 1.33, we get 7.9427 times 10 to the 24th power. Now, considering Earth's radius is 6,371 kilometers, we multiply that yet again by 1.33, we get the new Minecraft's world's radius, as if it was a cylinder, being 8,473 kilometers. Now, if we plug this back into the original force equation that I have earlier, we will find out that the acceleration due to gravity in Minecraft is actually less than Earth's. It's 7.38, notably closer to Venus in our solar system, so it's actually a lot less. Actually, if you weighed 142 pounds on Earth, then you would only weigh 107 pounds in Minecraft. So, Steve weighs about 107 pounds. If he only weighed 107 pounds, you figured a steak would fill him up in one go. Still takes 3. But by finding this gravitational factor, the gravitational acceleration, we will be able to solve a lot more stuff, like the terminal velocity, and if fall damage is actually accurate to the human body. But we'll have to save that for another video. I want to thank you guys so much for watching this video. If you did enjoy, please leave a like. That'll also encourage me to make more of these science videos in the future. If you have any questions, put in the comment section below, and more information on the math will be in the description. Until next time, guys, jblader111 signing out. Thanks for watching.